thanks for being in this big amount of numbers. I was expecting a little less interest, but that's completely fine. So my talk is going to be about implementing a large-scale data mesh at PostNL. Basically, my very first question is, are there people who are currently working with what I would consider traditional architectures? So data lakes or data warehouses? Quite a lot, all right. So this talk is aimed at not bashing on those traditional architectures. It's about giving a different perspective on how to handle these big amounts of loads. So I don't want to become negative or anything, but I hope everything will be explained within the presentation. Also, one side note. So obviously, AI is the thing for generating all kinds of things. I was looking for content to visually make my presentation attractive. However, I used just a pencil, like I have an iPad, so I drew everything. I hope it makes sense, but it's not AI generated. So expect some weird handwriting and stuff. But I hope everything's readable. Anyways, my name is Dronk. I'm a software data engineer, depending on where I work and with who I work. You can find me on Twitter with the handle @PatrickDronk. I'm via the same name on GitHub. The slides are on GitHub if you're interested. And that's about it. So let me give you some context or background about PostNL. PostNL is currently the leading parcel carrier of the Netherlands. We deliver over 7 million letters a day, and we deliver over 1.1 million parcels a day, actually, which is quite a significant load. It's a company that's already 220 years old, which is, like in terms of a lot of tech companies, it's really old. And they had to innovate quite a lot during their period of existence. So they had to conform to basically traffic. The moment they started, there were no trains, for example. So everything had to go with, I don't know what, horses or something like that. And eventually they had to adapt to all kinds of changing situations. And I think Corona is the last one that actually changed the whole e-commerce systems. And so PostNL had to scale with it. Currently, they're on the digital transformation hype, I would say, something like that. And the data mesh is a part of this. And I think about 4 years ago, they were creating a data strategy within like some departments of PostNL. And they wanted to do, or they wanted to make data-driven decisions. And so they started with like these role containers that you see here. It was actually funny because nobody knew how many of these things would be there. And we had no information about them. We didn't know how many there were like in the whole of the Netherlands, but we also didn't know on which location they were, what kind of status they had. And yeah. So eventually they started with beaconing these role containers. So these beacons are like small IoT devices that would have a GPS system in there, and they would have a gyroscope. So you would actually know if what you could do is the bottom side, you could flip it up so that you can like get these role containers inside each other to save space. But it also meant something for the process of PostNL, what this role container was going into. I think this process took about a year, and they finished about 2 years ago. And we actually have over 300,000 of these role containers going through the Netherlands and like the whole of Benelux, actually, going on. And they send a lot of data. So I think that the last number that I can recall is 200 gigabytes a day, which is actually really significant. And from that point on, we started looking at the whole data platform as we knew it. So we've built a data mesh, and to illustrate what the data mesh is actually trying to do, I would always, if I would have to talk to somebody that didn't know something about data platforms or the data mesh at its whole, I would take the example of this bucket of Lego. And I would say, hey mom, so imagine that I'm trying to build stuff with Lego. I would go to this box, I would search for the data that I need, and I would build things. But along the way, more friends would join, and we would be building out of this same box. And we were running out of pieces, or we had different needs of the pieces, or all these kind of things. And this is where larger organizations like PostNL, they didn't really had the ability to scale that very well. So they had a lot of data, but giving it to teams and doing that in a good manner, it didn't work that well. They actually they had a product which they called Daisy, and Daisy was like the flower daisy, so they had this centralized piece and all these leaves between them. And that was basically the centralized way of how they were doing it. They were building it via a vendor, and this vendor actually took a year. I think that the whole flow was wrong, and it's not per se the vendor that did things wrong. But eventually, they came up with a product after a year, and it wasn't usable. They weren't getting any usable things out of it. And so they decided to build something of their own. So eventually, so let's look at the key principles of the data mesh as a whole. So in its nature, it's decentralized. It has domain-driven ownership. I will have some examples in a couple of slides. All the infrastructure is self-serviced. It is semi-governed, so you're actually allowed to do a lot of stuff, but not everything. And it's resilient and scalable. And I think the resilient and scalable and decentralization are tightly coupled together. It's not anything like Bitcoin, but the decentralized nature is something that really is apparent in the whole data mesh. If you would compare both, so the traditional architectures, I would consider the raw or the data lakes and the data warehouses. And so obviously the architecture is decentralized versus centralized. The data ownership, it always remains at the team that produces the data, so not the data lakes or the data warehouses. The infrastructure is always self-serviced instead of having one team having to manage a whole cluster of basically data management services. The governance is semi-governed versus where the centralized structure is most often strictly governed, but it doesn't have to be. And the last one is a bit opinionated. I'm not saying that traditional architectures can't scale. It's just harder to scale. So they can scale, but it's harder. They have a lot of data. They have a lot of producers or consumers. So it's just harder to scale. Let's look at how we implemented the data mesh at PostNL. We basically built 4 products, which I will go into, but that you know the flow of the presentation, basically. So we had the synchronous gateway, an asynchronous gateway, we had a raw data gateway, and eventually we had an explorer. When I actually started at PostNL, so they asked me, well, actually, me and a colleague, they would ask me, hey, we've got some ideas, can you come and help us? And there was my platform owner, at least that's how I interpreted him. So he was telling about this Daisy and everything went wrong, and I have this awesome idea that we do things completely different. And at the time, I think this was about more than 2 years ago, the term data mesh wasn't actually being talked about. We only learned afterwards that we were doing things that were highly comparable to that data mesh. And eventually we looked at the data mesh and were conforming more towards that structure. And this was basically me. I didn't understand what he was saying. He had this big plan which he wanted to achieve in a couple of years, and I was like, I just don't know where you're going. So what we actually decided was, let's just start adding value. So basically we're here with a mission, and that's making data-driven decisions. And what PostNL is a digital company, or like it's going to the digital transformation, but they're not there yet, not at all actually. So these role containers, all right, so we had a lot of data, but we knew at which locations they were, but there were no applications that were showing it. So we had some discussions, we had some interviews, and basically we could get people happy by letting them know how much role containers would be on which locations. So at the end of the day or at the end of the shift, they could send some role containers to another location because, I don't know, bol.com has like Black Friday or these kind of things. So they could structure that very well. And now they would just call each other, email each other, how many row containers do you have? 1, 2, 3, and that didn't work very well. So we identified, all right, let's build 2 services. The first one would be the business location registry. So which locations do we actually have? We went to our domain experts, if you like to call them that way, and we asked them, so where can we find any information about locations? And there was this dangling XML file somewhere that you could get, and so we took it into our application, and we would expose it via an API. The other service that we needed to have was the asset registry. This was actually the one that was keeping track of all the row containers, where they were, what kind of state they were in, etc. So we would get events from these row containers, we would get them into the domain, and eventually we would expose some amount of data of these row containers via an API. And I'm only talking twice about technical implementation, but I think that GraphQL in this sense, and actually federated GraphQL, helped us understand what the philosophy behind the data mesh and the part of, and a really important part, governance, which I think is the hard part to do. The GraphQL actually showed us how to do this, or at least it gave us a lot of ideas. Again, if I would explain to my mother what GraphQL would be, it's an alternative to REST for our engineers, but you can send a blueprint of the data that you want towards a GraphQL server, and it would give you only the data that you need. So this is actually the SpaceX API. I hope everybody knows what SpaceX is. It's the company of Elon Musk, which sends roadsters into space and want to get Mars inhabited. So here you can see a blueprint. So what we're actually asking here is, hey, from the company, I want to know who the CEO is. So we would run the query, and it would say, Elon Musk is the CEO of this company. But there is more data available. So I think the roadster property is here, and we can actually, I don't know, get a lot of data, right? So I think the speed in kilometers, obviously. The current speed now is 9,520 kilometers an hour. And so this is what GraphQL is. But there is something more to GraphQL. And let me see if I can get to the next slide. No. Give me 1 sec. Well. Yeah. All right, so the term federated GraphQL is about merging the schema definitions together. So the schema definition is the definition of what you're exposing, so your API definition. It's hard to get a simpler word out of it. So it's just what is available on my API. And what this gateway, which was in front of our services, would do, we could actually relate the data that was coming from the assets towards locations. So we, in SQL terms or something, we would set up relationships between entities. And this gateway would actually know the existence of several services, 1, 20, 100, it didn't really matter. It was going to try to get all these definitions from all the services that he knew of, and he would try to merge those schemas together. And when those schemas were together, consumers would always see a fully definition. So imagine if these were just regular microservices, you would go to a business and then go to the assets and then ask for all the asset at a specific location. At this GraphQL, this federated GraphQL, you could actually ask, give me the business and all related assets, just in one query. The gateway would do it for you, basically. So it really gave a good understanding about what kind of entities there were. There was one big problem. We were working with 2 teams at the time, and these teams would build their graphs. And if one person would work at a graph and another one would work on another graph, and they would have some conflicts in these graphs, the merging of these graphs would actually fail. And that gateway that we initially had would break because it was expecting or inspecting those services that were downstream. So here's the first piece of governance that we actually thought this makes a lot of sense. So we introduced the schema registry. It's not something that we came up with. It's some companies are doing this, and I think a blog post of PayPal actually inspired us to build this. And so what would happen is engineers would work on their schemas. They would send it to a schema registry. It would know all the schema registry and the versions of it, and it would try to merge the latest ones. If it was able to merge everything went all right, it will create the full schema definition, and the gateway would always have a working piece. If on one side of the engineer side something would break, so we had GitHub Actions, the GitHub action would just fail in your pipeline, and you will not be allowed to push anything further to the schema registry. And now we had a happy customer. They could finally see how many role containers are on which locations. Let's talk about the next product that we built, which was the asynchronous gateway. So imagine, so I already talked about this one, right? So we were getting events. But what was happening here was these events that came in were raw events. And with raw events, I mean that these events were just saying, I've changed location, these are my new coordinates. I've changed location, these are my new coordinates. It's not saying anything about entering or exit a location or knowing something about the state of the role container, so that bottom one that could flip up and down. We noticed this already during development, but along the way we've built these products. And so we identified this to be something that could be really valuable, because they would get the raw events, location change, and eventually they would say, hey, I've noticed that a specific role container entered a location and it exited a location. So instead of interpreting all those raw events, they would create domain events, as how we'd like to call them. There's one thing I need to mention that really helped us with building the data mesh, and that's our infrastructure as code. So people were allowed to basically build everything in their own languages, with their own toolset, with whatever they wanted. There was just one consensus, and we would build everything with infrastructure as code. We would use AWS CDK, which would generate CloudFormation, and we would deploy all our infrastructure via that. What we asked from teams is that just include a part of infrastructure that we can manage. And so this drawing actually resembles the way that we reserve the part of their cloud that we would manage. We asked them, so at the meantime, they had like multiple services generating all kinds of events. We would say, just send them towards our event streaming solution. We will give you an entry point. Just send them there. Even though if you don't know who your subscribers are, or you have no subscribers, that's all fine. We will make sure that if there are any, we will manage it for you. So eventually it would work something like this. So on the left-hand side, let me get my mouse to go away. So on the left-hand side, we would have the assets team that would produce these domain events. It was not going anywhere. But team B was like, yeah, we really want to know when an asset exited a location, because, I don't know, we need to call off trucks or whatever. So they would actually go to our data mesh, and they would ask, hey, I want to subscribe to this. Our data mesh, our gateway, would actually go to the specific account, to the infrastructure that we manage for them, but they host them itself. And we would set the forwarding rules to them. So we would say, hey, this account ID wants to know about this event, so start forwarding it. And that would happen like almost instantly. And so this is just everything that I'm telling is highly simplified, right? So there are a lot of moving parts, a lot of authorization things, a lot of things that you need to consider, but this is like the fundamental thing. Then we had another thing coming to us. So we had this machine learning gurus or like AI stuff, and they were actually asking, so we understand this GraphQL part. We know it, we see value out of it, we see relationships forming, but how do I get large amount of data? Like pagination is cool and stuff, but I need more than 20 results. I need like gigabytes of results of the last, I don't know, 3 months or something. And yeah, so that was not going to work out for them, the events or the GraphQL. And so what we actually did was we took this exact same approach that we had initially with the event streaming solution, and we did the same for the raw data. So we didn't judge what kind of data you were sharing. If it was a database backup, I mean, sure, if that's what you want to share, go ahead. If it was any other thing, a JSON or whatever, they would just send it there. And eventually, it's the exact same flow as we would have with the event gateway. But now, instead of like creating forwarding rules, we were replicating data towards the team that actually needed. So in terms of that buckets of Lego, we would now give them a specified piece of Lego piece that they would need to build their products. Now the data team that actually made these machine learning models were actually happy. They could have data. They had like 500 gigs of something they wanted to have. Replicating all the data took a while, but in the end, their requirement was we just need the data. We don't care about if it's a day more or less. When building all these products, we noticed that we were having some issues. We were growing quite a lot, so we started off with 3 teams, and I think after 6 months we were with 7 teams, and like they were like pumping up the recruitment. And eventually, so we identified, all right, so this is our data mesh, and everything's decentralized and everything works well, but we have no clue what is happening. It's like this is subscribing to that and events going everywhere, and we had no idea who was subscribing to who. Yeah, we did, we knew it, but it was in databases. It wasn't visible, there were no relationships between those things. Well, we had a lot of teams already, and we actually had a couple of other teams within PostNL that said, hey, we want that data as well, because we don't want to read all these static data files and stuff. So my platform owner came again to me and he said, I got the solution. I got it. And I remember this really well. And he said, we need something like the Yellow Pages. He isn't a really old guy, but apparently Yellow Pages was the first thing that came to mind. And I think I just said, yeah, let me think about it, because honestly, I don't see any resemblance with Yellow Pages. But, and I think it was in February or January, and actually the ThoughtWorks Tech Radar came out. I think you know it. It said a lot about things, about what is happening in the IT world. And on the tools, actually Backstage was one of the platforms that would be in the adopt phase. Backstage is a developer hub, basically, developed by Spotify. And they had a similar issue. They were growing quite a lot. They had over 100 engineering teams. And how do you make sense of all those microservices and all these distributed teams that will work on a specific part of what is Spotify? And so they developed Backstage, which was their development hub. And they also had something that they would call plugins. So you could actually adjust the whole platform to your need with all kind of plugins. To understand what Backstage meant for us, in the first moment that I started with it, they talk about entities a lot. And these entities would be these 5. So we would have system, we would have components, we would have APIs, we would have groups, and we would have users. And one cool thing about this was we could actually set up a GitHub integration or whatever Git provider you would have. And what it would do is would just scan your whole organization. It would create all the entities for users. It would relate them to groups and eventually also systems. So basically it always assumed that a GitHub repository was part of a system. And like the middle one, the APIs, is something that we already knew. We already knew this because we had this decentralized world, right? So the event gateway knew relationships between specific products. So one was producing event data, and the other one was consuming event data. And it was for all these things. So where we used to manage all our event definitions and all these relationships in databases and on Confluence, where we had to do manual updates of all these things, we now had an easy way of automating this via our gateways that would actually now do the orchestration of the whole data mesh, but they will also talk to Backstage to inform them, hey, something in the mesh changed, this is the new world. And now everybody could look at what this organized chaos was, basically. This was it. I was not allowed to show you any other parts, but we could change it into, like, you can take full responsibility of the whole project. So you could, like, do the styling, create plugins. So I think that the playground one was the one that you could just query the whole GraphQL engine that was there. So the whole world would be there. And we actually published our own plugin, which is the Voyager, which would inspect the whole graph, but it would now draw it with nodes so that you could understand relationships without seeing too much implementation of the data. So all the attributes and what kind of types they were, we omitted that. We just wanted to see what kind of objects are there in our mesh. Yeah. So I'm okay on time. Let's talk a bit about building the mesh, because up till now, everything's working all right. We have some challenges, we have some things, but these would be the things that we would consider when building the mesh. And one of those things is the data product thinking. If you would look at traditional teams, they would not treat their data as a product. They would build an API, which would be a product, but the data that they would expose towards a traditional data lake or whatever, it is like, publish it, not my problem anymore. And in this sense, now it is your problem. Things will be copied over or sent towards other teams, and you should always be really careful about what your product is. The second one is, I think, something that I already showed, that we were really invested into delivering value towards our consumers. In our sense, it was like building an application. But in this sense, teams had to adjust towards that. There are not only applications that you build, there are also people outside of your world that build applications on your data as well. And that's something that they had to, or that you need to consider. And the last one, establishing clear data product ownership. So what will happen in our situation, we didn't work with this, or we didn't think about this at the time, but we were building the business location registry that was having a source, which was that raw XML floating somewhere. And actually some users of the application would come to us and would say, hey, a part of this data is not correct, you need to change it. And we're like, that's a good one, but if anybody knows from who is owning this XML, we can get there, but up till that point, we weren't actually able to change it. Yeah, we could, but it would like be asynchronous, and then you would have different parts of data across the company that would be incorrect, at least at one side of the data. Another thing that we really saw shine within our PostNL data mesh thing is that we would have these domain-specific teams. And I think that asset team is a team that really shined when building the mesh. So they would take these raw events, create very valuable events that would help other people within the company to build their products better. And this asset team actually only had 2 or 3 engineers, and we had to change. So PostNL didn't have any product owners or platform owners or whatever. Like, we grew into this, and our PO, so the one with the tie, he actually was a product owner, but also a data product owner. That's how we started calling them. And we had business analysts, and they went really well, really fast, and they knew everything. Engineers would build, the data product owner and the analyst would know all the context about whatever was happening with these assets. And it just went really well. This is the second part where I will talk a bit about technical details. So all the teams within PostNL would get their own AWS cloud environment. And like the DevOps mentality was really there. So we tried to automate as much as we could, which was actually almost everything. For our infrastructure, we used AWS CDK. For our whole CI/CD, we would build GitHub Actions. Either they could use public GitHub Actions. We had some private GitHub Actions, which would set up credentials for AWS, which would have interactions with the data mesh. And that's what we've been doing. And this last one was a huge enabler for our team. It is called ProGen. I'm not sure if people heard about ProGen. It's like a product builder. So for people that work with Spring, for example, you go to start.spring.io, you mention, I want to have a Mongo connection, or I want to have Postgres or whatever. You click generate, you get a whole file. It already has connection with the database and all these kind of magic things. However, ProGen aims to not only generate project, but also maintain and incrementally change the project. So it would be a dependency of your files. So you would have your dependency manager, and you would have ProGen as a dependency. And what would happen is, the example is, we would have a base file. We would have no static code analysis, because we weren't interested in the beginning. What we did, eventually, we would change the base project, and we would say, okay, let's add static code analysis. We would push it to the base file. The projects that we had in GitHub would be enabled with Dependabot, which is a dependency checker and would make pull requests and these kind of things. We have set it up to merge on these specific dependency updates. And what would happen is, I think the last time I checked, we had over 200 repositories. With one dependency update on the root project, basically, we enabled static code analysis on all of our projects, which was basically like we were flabbergasted that this was so easy, because normally this would take a lot of time. So if you have interest in this, do check out ProGen. I think it was one of the big enablers for us. Governance and standardization is something that really, that's personally, I think, the hardest thing to do. We had some policies, but these were most often the functional policies. So actually what we would say is, are you able to break things? Then we would set up a policy. So, but what sometimes would happen, we would have like this Dutchlish. So some English, some Dutch, and yeah, that's not really what we wanted for the data mesh. We wanted to have English only. But there wasn't really something that we could do about it. So this governance and these policies about creating data products, they were not really there. Security-wise, we did our best, but I think that product owners are not really concerned with security unless it's too late. So we did our best to do as much as we could, but we still knew that there were some improvements to do. Not saying that we were insecure, but we knew some things that could have gone better. The challenges that we had was balancing autonomy and governance, or at least that's one of the parts. And because team had a lot of governance, they would just spin up Kotlin application, they would spin up Python applications, JavaScript, TypeScript, Go. We had a plethora of languages in our landscape, which was all fine, but if you want to consolidate, if you're growing and want to consolidate some things, or want to maintain projects like we did for a lot of teams, we had to support all those languages as well, which was really hard. So giving the people enough space to innovate, to build amazing products, and to go fast and go well, or have the governance and make sure that they align according to all kinds of policies and those kind of things. It's hard, because it differs from team to team as well, I would say. As I've mentioned, PostNL has been in this digital transformation, and changing the business was also really one of the challenges. So they work, I wouldn't say they worked with Scrum or any agile methodologies, but they just changed from one quarter to another, from doing no agile at all to implementing large-scale SAFe, which like they hired 10 people to fix this, and in the end, we were saying, hey, we do Kanban. This is what we tried to deliver, and yeah, you have to deal with it, because that's how we wanted teams to be acting. Just focus on delivering things. And the business had to adopt to that really dynamic way of working, but also the data product owner was a new function, and we would transform domain owners to these people that would actually start owning digital products, which was really new to them. Some liked it, some didn't, and so a lot of things changed there. But there was a big challenge that we had from the business perspective. Another challenge, obviously, was the complexity of the data ecosystem. So one part was the Explorer that we already manage, right? So we made a centralized place for the whole decentralized world. So we could go to Explorer, see what relationships there are, and those kind of things. But in the end, we also had a plethora of data files that teams would start using. So it would make sense to always use a JSON for all of our communication between teams. But we also had some low-code developers that would only be able to generate XML or Avro or whatever. And you would have an issue because they wouldn't have the same engineering capabilities as that the people in our department would have in the e-commerce world. So in the end, I think these were at least 4 things. So the GraphQL is just an example, but Avro, Parquet, XML, and JSON were the most used ones. And yeah, a lot of people, some people wouldn't know Avro, and yeah, they had to learn it. And this was just a challenge that we had as well. People had to learn a lot of data structures. All right, so coming back to our gateways that we've built, I think the result in that is that almost everything was decentralized, apart from that specific GraphQL gateway that would route traffic towards the specific teams. We decided to build it in a serverless environment, so don't care about scaling. We had a good performance test on it. We had a lot of monitoring and tracing behind it, so we weren't actually worried that that was going to be a big failure in the future. Everything was domain-driven, so we would build teams not by something we think is a domain, but if people would talk about assets, we would create an asset team. Even though we can talk about role containers or like these bags that would have packages in them as well, these would just be assets because that's how they talked. So we were actually focusing on domain-driven. Don't do any assumptions. Everything was self-serviced, so if somebody wanted to join the mesh, we didn't have to do anything. Well, not really true. We had a list of accounts that could access the mesh. And if you weren't in there, we had to add you. That was the only thing that would be a manual job. All the other things were self-service. You want to join the event gateway? Fine. Here's the documentation. Go ahead and see if you can connect. So it was semi-governed. So we allowed a lot of things as long as functionally everything would work. And it was high scalable. So I think most of the time we opted for all kinds of services that were serverless by nature on AWS. So we didn't have to think about these things. And even though like the IoT team were producing these 200 gigs a day, there was no team that actually came to us, we can't handle this, or we have issues in scaling our stuff. So that worked really well. Eventually, the teams experienced an improved scalability and agility, and I think that ProGen part that I talked about, so that project generation and maintenance, was a big enabler. And I remember that I was just working one day, and there was this new person who was being onboarded, and he was assigned a task: deploy an API, to just get an understanding about how PostNL is working currently. And he would actually go into the Slack and would go into general, and he was like completely amazed. Within 30 minutes, he had an application just with some mock data, but he had an application on all 4 environments without having to know a lot of things. He would just generate it, everything would set up. He would say, I want to deploy it to development, test, acceptance, and production. It would generate everything, and he would deploy within a reasonable amount of time. One of the other results is that we had we tried to build an open source community as much as possible. So most of the teams would build on domain products, so they would, I don't know, build something that needed a database. And if they had some other requirements, either they would build it themselves or they would come to us and they would say, hey, can you help us build something with databases? So sure, we will gladly help you, because we were trying to enable these teams to build products faster. But eventually we just made a concept of things. And if teams would want to change something, these were all like global libraries, they would just change a part of the infrastructure and they would say, hey, if you want to use Postgres, that's fine. We've added a flag that you can use MySQL, or if you wanted to have daily backups or monthly backups or whatever interval you want, we've added this because a team needed it. And you really saw that they were looking collaboration between the teams. So they were changing things for their own benefits, but was also considering the whole people around them. And even, I think, observability is one really big topic that's going on in the whole engineering world. And they decided, so this is a big topic to just pick up for one team or one person only. So let's make a guild, or let's make a team, or how do you want to call it? They would just take people from different teams and work on a specific project every sprint or something to set up observability. All right, so concluding, we've talked about the challenges of the monolithic data architectures. We talked about the data mesh concept. We talked about the data mesh at PostNL, so how we implemented this architecture. We talked a little bit about the things that you should consider when building the mesh. We talked about the challenges that we faced during building this mesh. And we talked about the results. This is it. I've got 4 minutes left. If there are any questions, come forward. Don't forget to rate the session. I would like to thank you all for your time and for your interest, and have a wonderful rest of the conference. Thank you.